Hello, welcome to Jerry Builds Things. I'm Jerry and sometimes I build things. Today I really raised the bar and start an electronics project that's so simple a child could do it. Stay tuned. Here it is, the famed Radio Shack 301 Electronics Project Lab. I got this thing for Christmas when I was a kid and it was like receiving the Holy Grail itself. The only problem is I only did a fraction of the projects. I would get bored, I wouldn't pay attention, I would just kind of flip through the book and just do projects here and there that seemed interesting. But recently I kind of wanted to get back into it and complete what I had started when I was a kid, because honestly this stuff still interests me and I want to finish something that I never finished when I was a kid. So I wanted to start by doing an unboxing of sorts. This isn't the original kit that I had when I was a kid. No idea what happened to it. It might be in my parents' attic. It might be in the trash. I'm not sure. So when I got it in my head that I wanted to redo this project all over again, starting at square one, I looked on eBay. I found this unit. The box is a little beat up, but it's all there. It's miraculously pretty complete. I had actually taken this out of the box after I had received it and finished a couple of the projects to start with before I had the idea to make videos out of some of these projects. But everything is still here and packaged the way I received it, which is pretty complete. Everything was still with the kit. So I'm just gonna go ahead and get into it now and show you what I got. So to begin with, here's the instruction book. All the projects are in here. Everything's pretty well sorted out. There's a lot of great information in here. All the components, it gives you explanations on all the components. All the schematic diagrams are explained. How to read resistors, how to read capacitors, how to read transistors, and then the projects themselves. Everything's there. Those of you that aren't familiar with this project, the notes had to be updated because the electronic industry changed the configuration of the transistor since the kit was made. So they had to kind of tell you how to identify transistor markings. Here's the unit itself. This thing was, as near as I could tell, untouched. So it's like I'm starting with a brand new unit, and I was really happy about that. Everything moves fine, switch operates, these switches are fine, terminals are good. None of these spring terminals are corroded or anything. They're all in great shape. Breadboard's in great shape. And my favorite part, because as we all know what happens when you leave batteries in something for a while, it doesn't look like any batteries had been left in it for a while, because none of that corrosion that gets left behind sometimes. And then the goodies are in here. All the components and wires. So I got it flipped around the wrong way. Integrated circuits, resistors. See, most of the resistors are still packaged up. I didn't take them out of the bags. There's some loose resistors from some that I had taken out of the bags to do a couple of the projects so far. All the transistors and diodes. And once again, I had it flipped around from what the description was. Here are the wires. The earphone for when you're using the radio. A semi-fixed resistor. And then all your capacitors, electrolytic and ceramic capacitors. Now, one thing that I did cheat on with this kit was I do remember as a kid not having enough wires of the proper lengths to complete my projects, certain projects anyway. When a project would get really busy and this breadboard would get really filled up, I wasn't paying attention to what lengths of wires I was using in the project. So I would have used all the longer wires, and then near the end of the project there's some connections I would need to make from here over to here, from here over to here, and I didn't have enough of the longer wires. So I was at Micro Center one day and I found a bundle of these things, these jumper wires, and they have the little grips on them. The ends are tinned. I bought these things right away as soon as I saw them, and I thought these would be perfect for this project. The only thing that I can see that might be a problem is on some of the more complex projects, this breadboard gets filled up with a lot of wires. And I do see these grips, while they're nice, they might take up a little more room because they basically triple the diameter of the wire at where the breadboard is. So I don't know. In between using these and the standard wires, I guess I should be fine. So there you have it. The 301 Electronics Project Lab from Radio Shack in its entirety. All the parts are here. Everything's in great shape. I can't wait to get started on it. So, that being said, I'm going to start with project number 1. So I'll tidy up the area a little bit. Project number 1 is a light-controlled bird. It says, here's an electronic bird that will sing for you from morning till night, but his singing changes as it gets near sundown. Follow the sections one at a time and step by step. So to start with, I'm just going to pick all the components that it has listed here. I did have to give myself a refresher course in how to read the color bands on a resistor. So if there's any of you out there that don't know how to read them, it's pretty simple. There's a ton of videos out there explaining. So 110K resistor. So that would be a brown, black, orange. Brown, black, orange. 10000. So there's our first component. 1k resistor. So we need a brown, black, red. I think I put one down over here. Brown, black, red. 1 PNP transistor, which is A and a whole bunch of numbers or letters. So first shot right out of the box, A. Got the transistor, 1.047 microfarad ceramic. You gotta go to the other tray for that. One microfarad is 1 million picofarads. So 100,000 picofarads is 0.1 microfarads. So 10,000 picofarads would be 0.01 microfarads. So that means I need a 47 followed by 3 zeros. So I need a 473. This is a 472, not the right one. Here we go. 473, which means it's a 47000, so 47,000 picofarads, which equates to 0.047 microfarads, I think. That's math in my head, not on a calculator, so we'll see. If it works out, the project will work. If it doesn't, then hopefully I don't melt something down. Learn by doing, right? 100 microfarad electrolytic capacitor, which is really nice because electrolytics are stamped with the actual number on the side. So it's not impossible to screw it up, but it's a lot harder for me to screw it up. Where there's a will, there's a way sometimes though. That's not it. That's not it. That's too big. Yep, 100 microfarad. Then we need a 0.1 microfarad ceramic capacitor, 100,000 picofarads, which would be a 1, a 0, and 4 zeros after that. So we need a 104. That guy right there, 104. And then it says 15 wires. I'm not going to count them out, just going to use them as I need them. So we're done with the components in that tray. Not done with the components of this tray. Need the wires. I'm just going to take them out and have them handy here. And I'll just start putting things together. Alright, step by step. Insert the 10K resistor in F11 and L11. 10K was brown, black, orange. F11 and L11. Insert the 1K in G13 and L13. Insert the negative side of the electrolytic. The negative side is also marked. It's the short lead. Insert the negative side in G15 and the positive in J16. So G15 and J16. There it is. It wasn't my idea at first to narrate this out loud, but I figure if I'm saying this stuff in my head anyway, I might as well say it. Insert the 0.1 microfarad ceramic capacitor in K17 and N17. So this guy, K17 and N17. Then insert the 0.047 microfarad ceramic capacitor in L19 and N19. L19 and N19. Done. Next step is insert PNP transistors, emitter pin in J20, collector in K20, and the base in L20. And they show the description right there of the transistor with the flat facing to the left and saying that the emitter pin is J20, so J20 the top with the flat facing left, the emitter is at the top. But what the note had said in the box about transistors being updated was this is what the transistor looks like now. And it doesn't have a full radius on the back side, but you can kind of tell how the radius on the sides is going in the direction that it would normally, so it's just like it's been chopped off. So the flat has the identification markings on it, and the flat face is left, just like the picture. So the emitter pin is up top here, while the flat face is left with the words on it. So it's going to go in just like that. Those of you in electronics and familiar with this stuff, I'm sure this is really old news for you, but for me, hey, it's new, because I've been out of the game for a long time. So J20, K20, L20. J20, K20, L20. So it looks like the base pin is connected to the ceramic capacitor down there. All right, next step is connecting the wires. I'm just going to shut up, read silently, and connect wires. All right, maybe I won't be silent. It's hard for me to do, admittedly. Connect the wires between the holes as indicated, or between the hole and terminal. For example, plus V3 to 48 means that you connect a wire to the third section of the positive row of holes and to spring terminal 48. Connect this wire as instructed. So V3 to 48 is here to down here, so we'll probably need a blue wire. V3, 48. V10 to negative, and that's going to be a short wire. That's right near the bottom here, both those connections. So I'm just going to use one of these short white wires. V10 to negative, done. And then there's just a list of all the rest of the connections. A11 to 36. V6 to 40. So that should be a red wire, should be fine. Now there are some YouTube videos where people are putting projects together on a breadboard like this, and they make nice crisp bends in the wire, and it practically looks like the diagram. It looks really nice. They look really cool. I'm not doing that. I'm a little too lazy for that. Some days I might feel like making a project look like that, but it's not going to be the case very often. And I lost my place because I'm talking. V6 to 40. V8 to 37. V8 to 37 is all the way over here. Another blue wire. V11 to 43. 43, another red one. V11. T11 to 42. T11's over here. 40, another red wire. That should make it. No, it doesn't. I miscalculated. T11, 42. L15 to L16, those are right next to each other, so I'm going to use a white wire since they're the shortest. It's going to be right down here. Alright, A15 to 25. A15, 25 is right there, so a red will do perfectly. F15, 26. F15, 26, another red. Just makes it. K16 to 41. All the way to here. I need a blue one. N16 to 39. T15 to 27. 27's the speaker, so another blue one. V15 to 28. And J19 to 47. 47's over here, so I would need another blue one, but I also have this green one. When I saw that there was only one, or not one, there's another one. When I saw that there were only 2 green wires, I was like, oh, maybe this is where the kit is incomplete. Maybe it didn't have, maybe they lost some of the wires. But then I looked at the parts list here, and green, 2. You get 2 green wires. That's it. So. Alright, it looks like I have all the wiring connected correctly. So the next step is to turn on the project. But also, before I do that, I didn't put any batteries in it yet. Alright, let's just switch it on and see what happens. So that variable resistor right there controls some elements of the sound. And then varying the light input on the photo cell also changes it. So on the how it works section, it doesn't really go into detail how the capacitance and the resistance of both of these here affects the sound or how the sound is generated. Since this is the first project, it basically just shows how the schematic diagram is correlated to the connections that you made on the board. So it ends up being a good starter project. Pretty simple, instant results. It was easy enough for me to put together, so that's a plus. So I think it's going to wrap it up for this video. I learned a little something. I got a good crash course again in how to read capacitors and resistors. And it was good to get back into this thing. I like these projects. They're kind of relaxing to me. It's nice and simple. So if you thought this was cool, give me a like, subscribe, comment, and I'll have more of these videos relatively soon. So until then, later.